So, Vulkan day number 2. Let's see what we can do this time. So last time we created a window that's red. It doesn't do anything, and if we resize it, it crashes because of things. I assume that the swap chain gets destroyed or something. Well, not destroyed, but probably because the size of the window changes, or the surface or something there gets invalidated or something like that. And that's what causes the crash, but so let's try to fix that so we could at least resize the window without crashing. So that should be fairly simple. We can just check if the window was resized. Okay, and then here we should be able to then resize the buffer somehow. How to do that in Vulkan, I don't know. In DirectX 12 it's fairly simple. You would say like swap chain and then resize buffers. You know, that's how you do it in DirectX 12. Of course, you would need to free or release the swap chain images, but like that's fairly simple. So maybe there's something similar. Resize. Okay, no. Okay, swap chain. Okay, no. There doesn't seem to be any way to do that, so maybe we just destroy all of them immediately. I don't know, do I need to release the images? Maybe. Release swap chain images. Do I need to do this? I don't know. I will not do it and leak memory if that happens. Okay, so now if we do this, and we can see that if we go here and resize, now we are here, it destroys them, and now we crash because now we don't have a valid swap chain anymore. Okay. Oh yeah, those don't need to be validated. True. Yeah. Anyways, then we can probably just recreate everything. That's a bit like that, but it's what it is, I guess. So let's do this. And oh yeah, this is a change I made. So it's like vsync enabled, and then this is like without any vsync. But anyway, who cares? Okay, let's remove that stuff. Yeah, it's fine, it's fine. I'm not sure, do we need to destroy the surface, because it never takes the thing. We probably don't. I don't know. Let's see if we destroy it and recreate it and whatnot, and then do everything again. Where do we get from there? And let's put this to immediate also. Immediate. Okay. Cool. And then let's just fetch the swap chain images. And now if we resize, okay, we got here. Okay, cool, cool. Whoa, it works. Nice. Cool. Okay, yeah, this code, let's try without destroying the surface. Maybe that's also a valid case. I don't know. We probably could read from somewhere, but that takes time. Okay, so the resizing works without destroying the surface. That's great. So probably, because this takes the handle to the window, it probably figures out that the surface was, like the window was resized, so it automatically does something to the surface or something, I don't know. And then, because it does something to the surface, it gets invalidated or something, and then the swap chain needs to be recreated because it no longer has the correct stuff in it. I don't know, something like that. But I'm too lazy to read about it, so we live with this. And yeah, now if we do render doc, I guess we will see that the buffer sizes will be different. Okay. Yeah, so print screen of that and then do here and see if there are different sizes. They seem to be. So yeah, this is Full HD and this is not Full HD. So yeah, it actually resizes the textures and buffers and what's not. So that's good. Okay, so next thing probably, because now we can see like we are running like 2,500 FPS. We could do something better by enabling VSync or making it like a parameter that we can give, like, hey, is the VSync on or off? So let's just make a boolean here. Okay, and then VSync enabled true. Okay, and this is, I think this was 5.0, first in, first out. Okay, and then we will just copy that here. And yeah, and now if we would, let's see, how should I do it? Yeah, let's make a function that creates the swap chain. Then go from there. Okay, swap chain. Okay, yeah. Create swap chain. And then we want the VK device property device and VSync both. Okay. Yeah, let's. Do we have that thing here? Okay, well that thing can go away. We don't need that anymore. Ah, yeah, we also need the surface here. Anyway. Okay. Okay, then swap chain device surface app VSync enabled. Yeah. Okay. Then we go here and we say VK yeah. Okay. Then what's missing? Is it complaining? Validate device. Yeah. Ah, yeah. Image count. Okay, what else is missing? We have app and all of that stuff. What is missing now? Images here. Oh, selected queue. Why does it need this shit? It's kind of annoying. Anyway, and then what else is missing? Ah, yeah, we didn't create a swap chain yet. Yeah. Swap chain. No. Then turn swap chain. Okay. And we are still failing. Why are we failing? What's the issue? Ah, result. Okay. Okay. Result is okay. Cool. And then this takes the chain image count and select the queue family index. Okay. Cool. Does it work? Yes, it does. Nice. And then we can actually go and replace this thing from here. Yes. Okay. And then we can use this thing. So let's do or input no is oh yeah put the input great is key pressed. Let's put like key base. No, what I want to do is need new swap chain. Okay, and then we do this thing, then async enabled, and then we do okay, or needs swap chain. So now, if we press space, it should recreate the swap chain every time and switch between the vsync modes. So let's see if we start it. Yeah, now we have vsync enabled, and now I press space, and we go on 2,500 FPS, so it works. Now we can toggle on and off with the vsync. That's good. Good. So I guess next we should I don't know what we should do. Probably try to allocate some memory from the GPU and fill a buffer or something like that with data and see it from the render doc. Okay. So let's do just an empty buffer first. VkBuffer. Buffer is null, and then we do VkCreate buffer. Yep. Device. Buffer. And then let's see, what does this eat? Okay. Creating for flags. I don't know. We don't need flags. Or maybe we do. Okay. Jump. I don't know. Let's make a 4 megabyte buffer. And VkBuffer usage. What should the usage be? Like index buffer. I just wanna. I don't know. Like, if you wanna like use this later on as a staging buffer or something like that to upload texture data, because at least in DirectX 12 you cannot go like straight from CPU to upload data to a texture. You need to go through a buffer. So maybe it's same here. So probably it's one of these. So it could be used as a destination and as a source, maybe. I have no idea. Probably should look up what these actually are. Am I even correct on my assumptions? But it's easier to assume things and then fix later. Sharing mode, exclusive. Selected family index. Then validate. Then let's destroy it. Complain to us. Device. Okay, now we should have a buffer, do we? Let's see. Let's capture a frame and see if we actually do have a buffer. Okay, we have one. Okay. So either there's bug in the render doc or I did something horribly wrong and render doc is not happy with it. Okay. Does it tell us anything? It's okay. Yeah, it has all the information like 1 megabyte and so on. So or did we put 1 megabyte? How much did we allocate? Probably a bit more. Oh yeah, 4 megabytes, yeah. But yeah, like, where does this memory come from? Or does it even have memory yet? So did we just create like a thing that says like, hey, I have this much memory, but then we don't actually have it? Because in, again, DirectX 12, you have few different type of like resources. Committed ones are the ones where you just give the size of it, as it is, and it also asks you the heap type and whatnot. And that lets you create them automatically, but probably here we don't have that because yeah, there is only create buffer or create placed. Yeah. So I assume it needs the memory. So how do I create like a? But then this doesn't ask for it, so maybe there's some other way. Vk create heap. No. Create memory. No. Vk memory. Map. What Okay, this takes device memory. Allocate. Okay. This is the thing. Okay. Oh. Yeah. Now. Yeah, let's call it heap. Okay, device memory. Heap. Okay. No, it's not validated yet. Let's check this. One gigabyte is probably enough. What the fuck is memory type index? Let's use 0. It's gonna be fine. Let me validate. Okay. And now, let's see what happens. Cool. But yeah, it probably, well, yeah, somehow now we need to use it. So, because you don't give it here, so is there like a, more, there is map memory, but it only maps it to the CPU side. And yeah, we wanna like tell this buffer where to get the memory. Buffer memory. No. Find buffer memory. Okay, so this takes the device buffer, heap, and then offset. And this sounds more like what I was expecting. That I would have it here as part of the call. So like here you would give the heap and then the offset. This is how I would do it, but I didn't design this. So maybe there's a good reason for this. Probably many people, but I'm too lazy to figure it out. Destroy. No, it's probably release device. Release me. No. Is it free memory? Device heap. No. Okay. So now, okay, nothing changed there. But let's see, does anything change here? So if we capture one frame and go to the resource, now buffer, and now it shows it here that it has been binded. So maybe we, okay, now it doesn't crash. So maybe last time it tried to like load something, it was not binded, so it didn't know where to go and it just crashed. Anyway, yeah, it seems to be empty, so does this work? Yeah. And how many of these we have? Okay, yeah, it has the whole 4 megabytes. That's cool. And yeah, let's put some data there so we can actually see that it has something. Yeah, where is it here? So we saw that there was this VK map memory, so we can probably use that. But then this doesn't know which buffer to target. So I guess it's just, Yeah, so we just directly write to the memory, not to some buffer. Okay. But we know the offset is 0, so let's start from there. I don't know. Let's do 4 byte offset. So from the beginning offset, and we will write, I don't know how much. Let's see. No, let's do VkBuffer. That's a better name. And then do length str. Yeah, we don't care. Data. No. Oh, what the fuck. Okay. And then we unmap the memory so we don't hold it for too long. DirectX is good to unmap it as soon as possible. And what should we do here? Yeah, probably like just do let's just do classic mem copy. Okay, we want the data to string, and then we do this many bytes. Okay, and now we started and we crash because we have a validation error. Memory type has 0. What does this mean? Oh, is it this one? So we need to find the correct memory type that supports this type of CPU bound thing. Whereas this is probably more like a host visible device local. Yeah, so this is probably local like video memory, so it's not shared between the CPU and GPU. Okay. Wild guess. Just throw random index until it works. Okay, cool. Yeah, but next thing probably let's figure out how to select that correctly, so we don't do this kind of guessing game for everything. Anyway, let's see what happens now. Okay, let's capture frame, then resources and buffer and view content. Okay, there's absolutely nothing here. Did we do it correct? Okay, char apply. No, there's nothing here. Okay, how about if we do this? Or does this return 0 or something? Copy source. Yeah, size. Okay. Did we do it? So now it's at 0 offset, so. Oh, wait. Oh, yeah, it should be fine, right? Actually, let's validate this date. Maybe we are doing something stupid here. That doesn't get validation. Cool. No. Okay. And then Let's see. Okay. Let's see the buffer content. View contents. No, it doesn't have anything. Why? Maybe we need to jump kilobyte. I don't know, 4 kilos. Let's do that. Like it definitely should put the data here, right? Unless I'm doing something really stupid, or it doesn't work this way. Or again, we have a wrong type of memory, but it doesn't tell us because reasons. No, there's absolutely nothing here. Fucking great. But here we bind the thing. Yeah, the memory of it's 0 in here. Yeah. So it should be there. Map flags. What are the options? Placed bit. Placed. I don't know. I wanna read. It's boring. Okay, so that clearly didn't work. I don't know. Final thing we can try. MZ. Data. No, 0x2D. Just try to do the whole array. Okay, it doesn't crash, so it clearly needs to do something correctly, right? Well, do we have like? Okay, we don't. Okay, cool. And now we go here. No, just doesn't have any data in it. Why? Who the fuck knows? I will figure out it later. Okay. So why we don't see any memory? That kind of sucks. Maybe it needs some flags or something. Sparse binding, blah 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 blah. This video device replay. No, I don't think so. Like this should have at least in gigabytes, so I don't know, maybe we just need to find the date, not find the data, but bro. Wait, what were the flags? Placed. Do we need it? No. Okay, this way, like we clearly get the pointer and whatnot, but still we don't have any data there. Why? Okay. Let's do this. So the data as yeah, it clearly is empty and yeah, it only has like zeros in it. So, but now after we do that, so it clearly wrote the data at least that address. But then unmap the memory. What if we don't unmap it? I would assume it would commit the thing. Right. It's so good here. Why it's not there? Like, why it's not here? Right? Like, why there's no date? I don't understand. It's probably something stupid I'm doing. I don't know, maybe this requires a restart. Okay. And this doesn't have anything. Yeah. Okay. That's what it is. Like, what do we have? We have memory. Can we see the memory contents? No, memory. Yeah. Test derived buffer. Okay, always bind memory option. Memory. Can I see that? Oh, no, it's this one. Buffer. View content. It's empty. Just guessing at this point, like, is there some like minimum amount of memory that you need to map before you actually, or it gets committed or something? Or maybe I should look for the memory type. Yeah, no fucking idea. Okay, we are doing something wrong. Memory allocation. Host visible. Okay, so we need to find memory. And how do we find memory types? It's probably like, okay, let's do this. VkGet memory properties. Okay, probably. I don't know. Unless there is like VkGet device memory commit. Okay, cool. Anyway, yeah. What was it called? Okay, physical device memory properties. Okay, physical device memory properties. Okay. Memory heap. Wait, what? There's a memory heap. Okay. Let's see. Okay, cool. It has the heaps, and then we select from those which of the blobs dot debug memory type spec index, and then property flags. Okay, there is a lot of them. Heap index 1 flags. Why are they this random? Anyway, who cares? We can then do memory heap count. Size. Okay. So I have 2 heaps. One of them is 68 gigabytes or something like that. And the other one is 25. Is that correct? I guess here we can see quite easily. Let's see. Yeah, 24. Is that? Hardware details. Does it tell us here? Okay, so this clearly seems to be the actual device memory. And then I don't know. Yeah, and then GPU. Wait, what? It's the shared GPU memory then. This one. So this is the shared one with the CPU. And this is the device only. Okay. But then based on this, how do I know which to choose? Of course, I need to choose this one because it's clearly the one that's shared. But yeah. Yeah. Okay. Then probably also could print all of those flags. That's like, it's kind of annoying. Like, how many flags are there? Like, find it. Thank you. Okay. Well, there's only 3, so this is like fairly simple thing to do. What do I call it? Print heap. Print heap info. VK heap. Okay. Then we go back. Maybe I don't do it that way. I will do it like this way. Yes, because there can be 3 of them at the max. And then we do this and device local. Otherwise empty. Okay. Yeah, let's see. The instance. Wait, what? Ah, the other one is KHR. KHR. Chronos. And that other one is just multi-instance. Multi-instance. Okay, and then we just, yeah. No. We take this thing, we bring it here. We could just print all of that information. Yeah, it doesn't matter. Okay, so it has. This one has nothing. This is clearly device local. It has the multi-instance on this in KHR. Wait, these are actually the same, right? Like if we go back. Like, oh yeah, these are the same. So this is just some backwards compatibility thing. Okay, fuck that shit. It's multi-instance. The KHR can go away. Let's do it like, nah, actually, let's just name the whole stupid thing here. Yeah, that's better. Then we know exactly what flag is in use. Okay, so now if we look at our thing here, it should say, yes, cool. So we have this thing and then we have that thing. Nice. That's good. This one doesn't have anything, so well, we could then do also like this. Zero, none. Okay. Cool. Yeah, this is none. Great. It doesn't have any flags. This one has flags. Yeah, that's okay. What else? Oh, yeah, because this has the local bit, so we cannot use it. But then how do these things work? Heap index 1, 2, whatever. And here it asked what? Memory type index. And we are printing. Where do we? Okay, so this prints the memory type index, which is here, and it says like what heap it is. Okay. And let's put memory type index here, and it's gonna be the I. Okay, and then property flags. Let's see. Okay, this one has more of them. Print memory type. Okay. Where do we have that thing again? Here. Memory type. VK memory type, okay. Print memory type info. Props. Memory types. Okay. Memory type. Okay. Type. Then let's do if type. Not printf, we have this thing, and then we do the okay, like this. Coherente. Okay. Easily allocated. Okay. Protected. Okay, cool. This could be made into a like a what is it? Macro. Yeah. Print flag. 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 Okay, then let's do this thing again. Print flag. Yeah, okay. This, then here. Then we say print flag. Okay, and then on the print flag. Okay, now that one here. So where do we start? Okay, heap type index, memory type index 0, device logo. Okay. That we need to remove because it's not really a flag. It's like a nonsense thing in a way. Okay, that's local. Probably the local bit. If index. Host visible coherent device host. So the one is not device, whereas the second one might be. Maybe, I don't know. Host visible device coherent bit AMD. I don't know. I will try the index 2. If with that we can get the memories to show up in the correct place. Let's see. Where do we allocate? Here. Okay, 2. Okay, nothing crashed. We didn't get any errors. That's all good. Okay. Now launch. No, don't save. Please let me get the memory. 2D, please, Peter. No. Why doesn't it fucking show up there? That's annoying. Like, am I doing everything correct? Okay, so we have a buffer, we have a heap, we validate everything. And we say like, hey, at the offset 0, please make my thing. And it doesn't. Or maybe this is wrong, so you don't do it this way. Honestly, I don't know. I have no idea. Are there some other things that we could turn on? Usage. Max N1. Can I just put it to everything or something? Uniform video, what? I don't know. Black. This will probably give us some kind of validation error, and it does. Yeah, actually a lot of them, because it's like, oh, you cannot, which are not organized member of. Anyway, it has been an hour. I will take a break and continue a bit later. Okay, so back here again. So I have figured out how to actually see the memory, and we didn't do anything wrong. And how can we see it? We make a capture in the first frame. And now, if we launch it, well, we don't need to press F12. Which one is this? Is the 0th frame, so the first one. So if we now go here, VkBuffer, And we got, there's the date. But why doesn't it take it, like, why it needs to be on the first frame? Like, the data is not supposed to go anywhere, you know? We committed it there. At least I assume it should be there. Like, who's overwriting it? No one. Then why doesn't it, like, know that it's there? That I don't understand. And then probably if we now open the other one, does this have the memory anymore? You can't, no. So it loses it after the first frame. But why? It doesn't make any sense. Let's try another way. Wait, no, why did I launch it twice? Idiot. No. No to all. No to all and no to all. Okay, let's try again. So 2 captures immediately after one another. Okay, so frame 0. We got resources here. We take our buffer view contents. It has the date. Then we go to the another one. Buffer view content. It doesn't have. So right after the first frame, it's like, I don't know where the data went. Who cares? I don't know. Who needs it? Like why? Why is the data gone? It makes no sense. Like, anyway, we know that the data went there, but it's like, I don't know what happens to it. It's just gone. So now, what happens if here, like after the frame, we're like, hey, let's map it and let's do like if. Did I have memory compare? Data is 32. Let's do it this way. I don't know. 2D, 2D, 2D. Wait, how many is that? 3. 2D. Or does this work? No. No. Yeah, it's correct. I just need to do this thing. And then size is 4 times 1, 2, 3, 4, 16. It's 0. If it's not 0, then jump log error. Why data gone? Okay, and let's do this one. Where should we do it? Where was the thing where we upload here? Let's just verify that data is there at the first time, right? Yeah, it is there constantly. So where does it go? Where the fuck does it go? We don't get anything like, oh, the data is gone. But now, if we discard all of these things and we go and launch it again, so now every frame we do this nonsense. And we go. So in the first frame, it should be there, right? And it is. Okay. And in the second frame, is it there? Oh my God. Go there. Okay. Resource inspector buffer. And it's there. So, okay, so if you don't map the memory or something, or touch it for a while on that frame, it's like, I don't know where it went. It's just gone. So I'm not sure if this is a bug in the render doc. Maybe. Because it should, at least I think it should stay there. Like, it knows that there is this buffer. So why wouldn't it know what the data is there unless you constantly go and look it up every frame? It doesn't make much sense to me, but I don't know, it's what it is. And what was the, yeah, we are using the, let's see, does it work the same way for the memory index 1? Yeah, the memory is still there, at least on the application side. So let's see, on this side, no to all, launch. Okay. I don't know why did I take the next. Let's see. Resource. Okay, it has the data. Cool. And then let's take the frame 71, resource inspector, buffer, it has the data. So you just need to keep touching it once in a while. And then it makes the render doc happy to show it. Otherwise, like, I don't know what you're talking about with this memory. Like, what memory? Anyway, yeah, it works. So, hey, we have memory. So, next, what do we do with all of that memory? Maybe we could try to plot an image. Not plot, but plit an image to the screen. So we would use that memory that the heap that we allocated, and then the buffer, we would push an image data, like bitmap, to the buffer, and then we would read it. No, we would copy it from that buffer to a texture, and then we try to see it in render doc. I think that's a good next step. So we don't need to go and we don't start to need to do any shader stuff yet. Anyway, that's the next step we will do. Yeah. Anyway, back to my short break. So, where did we left off? Oh yeah, we got the memory showing up. After figuring out that the render doc probably has some issues, or we don't fully understand how Vulkan works, so without touching the memory or mapping it and unmapping it, we probably will not see it. So anyway, we know it's there. We check every frame. So next thing was to load some image. Yeah, so let's try to do that. Let me look for some kind of image. It would be like an okay thing. What's the resolution? Properties, security details. Yeah, that's okay. Test. Okay, so now let's try and load the image data. I think I already have STP image. Okay. Implementation. Yeah. Build. Okay. Now let's load the data. Okay, it can go. I don't know. Let's make it a bit larger. Let's make the whole thing. Cool. And then, yeah. What do we want to do? Let's load the thing. So the bitmap. Step load data. JPEG. Bit. Width. Height. Bitmap channels. Step and then we do yeah, and then let's put this. Okay, channels. So after this, there will be 4 channels, so we can just do set bitmap. Okay. Yeah. So now we should have an image. Why data gone? Okay. Yeah, so now we get this why data is gone, because of course we are now comparing it to some values that are no longer there. But let's remove this for now. We don't need to do that. We know that the we actually managed to get the memory there. And now we need to write this bitmap to the heap, not the buffer. So we do mem copy data bitmap width times height times 4, I guess. Yeah. Okay. Yeah, we don't have any errors or anything, so it's good. Now let's go here, not all. Launch. Let's just capture the first frame, launch. Okay. And then let's go and see what do we have in the resource inspector. Okay, so yeah, these look like color values, so it's clearly like alpha channel, maybe red. I don't know which way these are. I guess this is probably red channel. I'm not sure. Anyway, so all the data seems to be here now, which is great. And now we need to create an image, I guess. VkImage. Validate. VkImage. Marke. Device. Yes. Find image memory, yeah, device, image, heap. That's the next option, I guess. But can it be bound to that thing? Maybe it can. But then if it can, then we don't really need to do anything, right? We could just... I let's see. Let's go and copy the things from here. I'm just assuming things work same as in DirectX 12, but they probably don't. So anyway, we will find out very soon. Okay. Now VkBuffer type. Image type. Okay, image type 2D. Image, no, format. R8G, 8 norm. Oh. Extent. Oh yeah. Depth is 1. Bitmap. Oh. Bitmap. Width and height is bitmap height. Okay, cool. Nip levels 1, array layers 1, samples 1. What is this? Tiling. I have no idea. This usage. Image usage. Okay. If you want to copy to it, we probably need to use this thing. VK sharing mode exclusive. Selected QFAMindex initial layout. VkImage layout general. Let's see what happens. And let's validate it. Okay, init. Oh, okay, undefined. Undefined. And now we don't have roster. Cool. And can we now do launch? Yes. Oh, I don't know why did I take a screenshot of that, but resource buffer. This should have all the yes. And then there should be a new image somewhere. Yes, 2D image. Let's see. Can we see this contents? It's a black image. Nice. So now my question is, what if we do this? Do we get the image? Okay, at least there were no errors. So maybe we will now have the image there. I don't know how Vulkan likes it when we do things like this, but hopefully it's gonna be like fine with it. Let's see. Because now buffer and image they are like placed in exactly the same memory. Is that okay or not? Yeah. Just the values and then the image. Nice. That's a photo of me. Great. Yeah. Nice. It's great. Now, what can we do next? We can try to draw it on the screen. Let's see. Okay, where is the acquire command clear? Okay, so can we now do like vk command delete image source image? This is then our current image, so it's the image, yeah. VkImage play out undefined. Okay. This is gonna be that. And it's gonna be this thing. Region 1. VkImage. Delete. Test offset 0. Business let's see. Okay, like that. Source sub resource. No, source offsets. Is this like the, does this define the quad or something? I don't know. Let's see. Bitmap. Width. Bitmap. Okay, filter. What is this? Oh, let's do this nearest. Cool. Where? Oh, I don't know. This will probably not work. Oh, it did. Whoa, it just sucks. There's some artifacts going on, but hey, that's cool. We did something. Got our first graphics to the screen. Anyway, let's stop. And yeah, after that, let's do breakpoint. So we get to see what are the actual okay, let's see. Validation error, required bit mask. Okay. Come on here. Aspect mask is 0. What? Image. Do we need to like VkImage aspect? Does this make more or something? I don't know. But who needs this aspect? Or is it because, like, at the end of the day, it probably just should be like this because there isn't any other layer. Maybe, I don't know. Let's see what happens. Yeah, it needs that thing. And then if we do like 32 and 32, some offsets here. Plus. Yes. Okay, cool. So we can move it around, but let's try to figure these ones out. We go destroy device. What? Oh, that's. Let's do this thing. What are the errors now? Okay, record a bit mask somewhere, something. Separation layers. Is it transfer source? Source image layout of common over. Oh. Source optimal. Okay. Well, there was this thing when we created it, right? That it was like, hey, it should be this and that. And we were like, okay, let's just put it to that. Oh yeah, it's this. But didn't complain that we pre-initialized, okay. But I don't like it if we need to do like a thing. Because I really don't want to do a thing where we do like an image barrier and then switch the thing. It's like, it doesn't really need it. Like, it shouldn't need it. Okay. Source image. Records usage transfer source. Usage. Yes. Okay, well, that's one of the problems. I learn how to read. Because yes, it's the source. But I was originally thinking that we would just transfer something into it. Okay, next problem is source image layout, object image layout. Yeah, this I don't like. I don't want to. For this, it sounds annoying. Remaining array layers must be greater than 0. Layer count. What do you need? This layer count is 0, okay. Oh, how is it 0? Array layers. Yeah. How can it be 0? Here is a layer count. Does this need to be 1? I don't think so. Let's see. No. Does it even work? No. Because they are where to where type of offsets, so. Yeah, okay, we have that thing now. Shit. Did we have any errors before that point? No. Then we do this thing and we immediately get a bunch of errors. Okay. I like how large this are. Regions and aspect max is 0. The fuck? Layers aspect max. What? Ooh. So apparently we need to do the thing that I don't want to do. Fine. Let's see. Destination layer count. Okay. Well, it should have 1, right? Anyway. Or do we have something swapped in that says like, oh, it's just 1. Layer count, layer count. Is there layer count here? No. The fuck? The fuck is it on about? Okay, anyway. Source optional. Aspect manager. Is this the source or what? Okay, well, whatever. Let's make another one. Chain image barrier. Yes, thank you. Okay. Transfer each bit. Okay, old undefined. Transfer. Source optimal. Okay. Each aspect needs to be what? I don't know. 2. Okay. Yeah. I don't care. It's what it is. Who cares? We get our image. Until next time, where we fix all the validation errors. Bye.